All right, so greetings, and welcome to Eureka Math Squared. This is grade 6, module 6, lesson 5, comparing data displays. Okay, so the first part here is really just talking about whether we should use a bar graph or a histogram. And the difference really is, I'll just grab two of these guys here, this guy over here. Here's a bar graph sample, right? And the reason really is looking at what is the next class on a student's schedule. We're looking at very limited, right, results here. Right, there's only certain subjects, so there are only certain subjects that you could have here, right? You have your little social studies, right? You have your little ELA, right? Of course, you got to put math in there, and what else? I don't know. Whatever, you got a little science in there, and lunch, phys ed, all that fun stuff, right? So you'll have a bar graph because every kid is going to fit into one of those categories. That's it. So that's really your bar graph fun. But this guy here, this is really histograph stuff. And the reason why is because if you're looking at a group of people at the hair length, everyone's going to have basically a different hair length. How could you possibly build a bar graph where, what are you going to put every single hair length down in here and hopefully you get more than one? No, it's not going to work. So what you're going to do is have a group, right, of, I don't know, anywhere from 3 to less than, I don't know, 6 inches of hair, and then from 6 to 9 inches of hair, and from 9 to 12. And it makes more sense to do it that way, and then to have bars to represent the groups. Okay, and that's basically the difference between your bar graph and your histogram. Okay, but that's not really where I wanted to get to today. That's just a little bit of a side note that they tossed in here. I wanted to talk about relative frequency. Now, we did talk about frequency before, and frequency basically is a number, right? So that's basically a number. So what we have here, we have some science club kids and they want to order some hats. So they measured their heads to get some, I guess, customized hats, right? So we go from extra small all the way to some couple of kids here that have really huge heads, right? Double extra large head, which is most amusing, I guess, right? So big old hat. So what we need to do here, they're looking for a fraction, but we need a denominator, right? So 8 out of something, 16 out of something, 8. They did the tallies already. So they gave us the frequency, right? So the tallies are somewhere else. I don't know where they are, right? They didn't show them. They gave us a total of 40. Now, guess what? Everything is out of that 40, okay? Everything is out of that 40. And that is our relative frequency fraction, right? So there's that 40 there, there's that 40 there. So your relative frequency, right, is your frequency out of a total. That's basically your relative frequency. Now they want you to convert to a decimal and then, of course, to a percent, which is fine. Really what you want here, let's see, if I want a percent, I want some value out of 100, right? That would be ideal. Maybe I drop this guy down to 1 over 20, right, by dividing both by 2. A little divide by 2, a little divide by 2. Once I do that, I can get right to my 100, right, by multiplying by 5, right? A little trick of the trade there, right, guys? 5. Now, as a decimal, that's 0.05 because that's 5 hundredths, right? And since it's 5 over 100, say 5 over 100, that's my 5%. Now, yeah, that's a lot to deal with. Okay, so if you're not so cool with the fractions like that, you can simply divide. So if I have an 8, I'm going to draw all over this thing. Just knock over that 8, okay? Put in a couple of zeros, bring in that decimal, and say that's going to, and just divide, right? So 40 goes into 80 twice, and there it is, right? So you have that 0.2. There it is, nothing left, right? So there's your 0.2. Right there, and as a percent, okay, that's going to be a 20% because if I have 2 over 10, right, that's really 20 hundredths. And now that I have a value over 100, that's my percent, okay? Or you begin to notice, hey, wait a minute, from all I have to do is take that 0.05, gain 2 place values, and it becomes a 5. Watch. See that point 0.2? If that point 0.2 gains 2 place values, let's do this real quick, right? You're going to have like a 5th grade nightmare over here. Watch this. Point 0.2 and it gains 2 place values. 1, 2, right? Now it's sitting over here. There's that 20%, right? So everything gains 2 place values. And me personally, I'm going to use this chart to help me out. So if this doubles from 8 to 16, then this guy doubles to 0.4, which means this guy doubles to 40%. Okay, and on I go with regard to this here, right? So let's see, there's another, this guy is the same as this guy, so he's going to be 0.2. There's 20% like that. And this guy's half the size of him, right? So he's going to be 0.1 or 10%, right? And this guy I did already, so he was a 0.05 and 5%. Now here's what's great about this. You have a built-in check. These guys here should all add up to 40, right? So I wind up with 40 out of 40. If I add all of these guys, all of my decimals, right? 40 out of 40 equals 1 whole. That should equal 1 whole. And then, of course, if a full whole here, 40 out of 40, I should get 100%, which is a great check. So if I just add these up, there's a 25, right? There's a 65 if I put him in there. 85, 95, add 5 more, and there's your 100%. It's a super check on your own work, on your own arithmetic, okay? And it works, which is nice. Okay, so let's see. Interval with the greatest relative frequency, that's not a big deal. That's my 40%, but they want the interval. So we're looking at the 550 to less than 570. So most kids have are going to need a hat that measures or fits that size there, right? Which is kind of cool. And here's some more of that stuff. Okay, these guys over here, and I'm just going to put the values in because what I want to do ultimately is get to the graph, right? So we have a 3 over 75. Now, when all else fails, folks, again, knock that over and divide. You're going to wind up with a 0.04 there, which is really 4%, okay? This guy's also a 3 out of 75, so he's 0.04 as well. Again, he's 4%. This is a 24 out of 75, and I have the kids use the calculator on this. Just divide that out, because I don't want them dividing all day long. It takes too long. Okay, that 36 is going to be a 36 out of 75, and that's going to be a 0.48. And as you would punch that into a calculator as 36 divided by 75, by the way, just so you know, right? We always read a fraction from the top down. 36 divided by 75. So now that's 48%. And next one is going to be a 6 out of 75. And that's going to be a 0.08 as a decimal, which means it's 8%. Next one is going to be, we're back to that 3 over 75, and I think we did that one already, right? So 0.04 and 4%. And then finally our total. Right, so if I did everything right, I should have a 75. If I add all of my numerators, I should have a 75 over that 75, which is 1 whole. And if I add all of my percentages, I should total 100%. Okay, so we just did 2 of those, all so that I can get to this little graph here. So they want a relative frequency histogram. So it's not just a regular histogram with values. We're using the relative frequency, okay, which is basically these guys here, right? So these guys here, the relative frequency, they want the decimal values in action here, which I'm not a huge fan of, but okay, fine. Let's see. So down here, we're going to have our values, right? And let's see. So we start at 50. It goes by 25s, and it ends in 200. So we have our 50. Right, 50 to our 75, to our 100, to our 125, to our 150, to our 175, to our 200. Okay, and these are our calories. Okay, per serving. And over here, it's going to be our relative frequency, right? Relative frequency. And again, not a huge fan of this kind of graph, but only because it becomes a pain in the neck just to map this thing out. So we have a 0.1, and I just have to keep going up, right? 0.2, 0.3, and I have to account for everything in here, right? So I go all the way up to this guy here is 0.448. So zero point 0.5 is going to be my, or 0.50 is going to be my max, right? So zero point 0.4 and then a 0.5. And then I just put them on in, right? So that first one, again, I'm bouncing around a little bit here, sorry. That first one here is going to be a 0.04, right? 0.04 right there. So 0.04, and I go back over here, and he's going to be less than half of that one, right? So he's going to be somewhere in there. Okay, the next one is the same, like that. The next one goes up to just over zero point 0.3, so he's like 0.32 or something, if I remember. Right, so he's going to be up there. Right. And then comes the big guy. He's just under 0.5. It's like 0.48. He's going to do that. Okay. And then we have two smaller guys. He's about 0.1, I believe. Right. And then back to that other one there. And there he is. Okay. So there's your relative frequency histogram using the decimal values. Right. There they are. And that's how it works. Okay. So um, pretty neat here. What's great is you actually wind up with a percent to represent each of the values, and you are representing everything all in one shot. So you're getting like the piece of the pie kind of thing. So if you're asking yourself, well, you know, how many kids here ordered this size hat? Well, you say, well, 48% of those kids, right? So it's kind of nice that way. All right, so that's the deal. That's what we worked on today. Hope you enjoyed that. And don't forget, math rules. Have a great one. Take care. Bye bye.